Alright, looks like we're live. Hello everyone and welcome to yet another recreational programming session. So let's make a little bit of announcement and officially start the stream. So let me bring my Discord server, right? So let me do a red circle. Live on Twitch. And what are we doing today on Twitch? We're making a web server using my own language. That's what we're doing today. That's literally what we're doing today. Isn't it Pogue? That's truly legendary stream. Twitch.tv/Tsoding. I hope. So, excuse me, did I make a typo? HTTP. Oh, okay, I see. So I'm supposed to actually put a colon in here. And I'm gonna ping everyone who's interested in being pinged. And there we go, the stream has officially started. So, yeah, you can find the source code of my language in the description if you're watching on YouTube, or in the chat if you're watching live. I'm gonna copy paste this entire thing in here. So, yeah, this is a concatenative stack-based language, right? And basically what I want you to do, I want you to expand the amount of examples that we have in here. I'm not going to develop anything fancy, right? So our language can interact with the operating system using syscalls and stuff like that, and that means it can use the socket API of Linux. And I thought, why not just like make a very simple web server, right? So just like HTTP, not HTTPS, and probably HTTP 1.1, just to showcase that you can do this thing in a language, right? So it's not going to be a production web server, just like, you know, a simple a toy example that you can put in here and just showcase to people, right? Like, look, this is what you can do in this specific language. So, and yeah, so let's actually do that. I think the web server is gonna just serve some generated HTML, right? And maybe we can basically even have a state. Why not? So if you go on a particular page, it will just remember something, and maybe you can do some actions, add some entries. Maybe we're gonna write a to-do app if we'll have enough time. Probably not. We'll see how it goes. Luckily, writing a simple HTTP implementation is relatively easy, right? So you just need to like send a bunch of text over TCP, right? So, and that means what you just have to do, you just have to like open a TCP socket and listen to the incoming connection. And our language is capable of doing that, right? I rewrote the whole language in itself, right? So it can actually do more than just open a socket and listen on connection. Hello everyone, welcome. How are you guys doing? So yeah, let's go. Uwu, I suppose. So let me just maybe bootstrap my language. I recently, just like right before the stream, updated everything, so I don't have any executables. So I probably need to bootstrap my language. The language is written in itself, so initially you don't have any binaries. What you have to do, you have to go into the Bootstrap folder where you have a pre-generated assembly of the compiler, and you just have to build that assembly. Right, so there's some instructions in here, Bootstrap, right, so you just have to compile a pre-generated assembly. So then I have to mark the executable as executable, right, because FASM for some reason doesn't do that by default, because maybe it doesn't know how to do that. And then I'm gonna recompile the compiler with itself, right. So, and then I can try to compile the next version of the compiler. And there we go, we bootstrap the compiler, so we can just keep recompiling the compiler with itself. And yeah, so we have a fully working compiler. And what we can do now, we can just look into some examples, right? We have a hello world. So here is the hello world, and you can just use porth run example hello world, and this thing should say hello world, and as you can see, it in fact does. And it's a statically typed native compiled language, so that means it generates native executables. So, and this is the executable that it generated, so it's ELF64 executable. And by the way, it is statically linked because our language doesn't know how to link dynamically. In fact, it doesn't know how to link even statically, right? It doesn't know how to link at all whatsoever. So it is what it is. So anyway, and that's why to interact with the operating system, you have to use syscalls. But that is fine. You know, we're gonna implement the linking in the future. It doesn't really matter that much. So we've got a bunch of subs. Let me take a look. Thank you so much, SA7 Mouth. I don't know how to pronounce your nickname, but thank you so much for 8 months of tier 1 subscription. I really appreciate it. And Sloggy1337, thank you so much for Twitch Prime subscription. Your first subscription, by the way. Welcome to our epic port club. I'm sorry. I don't know what happened to me. I think I had too much caffeine today. So anyway, let's actually go ahead and like write an application, right? So let's actually call it http.port. And the first thing that we probably need to do, we need to include the standard library of Porth, right? So that's the very important thing. So our standard library doesn't have anything related to opening sockets. So we'll have to implement that from scratch. But as we implement that from scratch, we'll have an opportunity to actually bring that in to the standard library. So it's not going to be just like, you know, a small meme project that we're going to throw away. No, no, no. It's first of all, it's going to go into the gallery of our examples to demonstrate what our language can do. And then it will allow us to move, you know, some network related stuff into the standard library so it can be reused in other applications, in other small applications. Right. So there we go. Let's just see if everything works correctly. Hello world. I'm gonna put puts in here and just let me verify that everything's fine. So http.port, and as you can see, it says hello world. So what we're gonna do, I suppose maybe we need to have some sort of a constant that indicates on which port we're going to be listening, right? So obviously, when we're developing these kind of web applications, we're always listening on the port 6969, so we're going to be using these constants throughout the setup of the server. And to be fair, I don't remember how to open a TCP socket, so I'm going to just Google it up, because I know there's plenty of examples in C. Right, TCP server in C, so let's steal some code. Okay, gigs for gigs. I probably should credit this website, right? So I'm gonna just open the description. So this is the wrong thing. So the first thing we're gonna have in the description, by the way, is the source code of the language, right? So here's the source code of the language, and here is the TCP client implementation in C. So essentially, we're gonna just basically port that implementation for Porth, right? So that's what we're gonna do. Okay, thank you so much. No. All right, so what is that? This is a TCP server, probably exactly what we need. All right, so there's some stuff in here that we don't care. This is the entry point. Okay, so the first thing we need to do, we need to create the socket, right? And this function accepts 3 arguments. Let me take a look at that function. So here is the le socket. Right, so it accepts the domain of the socket, the type of the socket, and the protocol. So as far as I know, in case of the TCP, usually it is enough to specify the domain of internet and the type of being stream socket, because there's only one type of socket in that specific domain of that specific type. There's only one protocol of that specific type, of that specific domain, and that is TCP. So that's why you can put 0 in here. And on top of that, I think 0 is also reserved for TCP. So it's sort of like a backward compatibility for a situation when you may have more than one streaming protocol in the internet in the future, which is quite unlikely because nobody remembers how to develop protocols anyway, so whatever. So we're stuck with TCP forever. In the era of web developers and JavaScript and React frameworks, we're probably never going to develop any new internet protocols, right? So because everyone is happy with sending JSON over HTTP for whatever reason. Everyone thinks that is fine and that is fast. Okay, so we've got 5 tier 1 subs. Thank you so much, QRDCV, for 5 gifted subs. I really appreciate that. And everyone who got the subs, welcome to our epic port club. How about it? Oh. I'm joking, by the way, so it's like being sarcastic when I said everything about the protocol thing. Don't worry about that. So as far as I know, socket is also a syscall, right? Even though this is like part of the, you know, socket API. I forgot, is that a Berkeley socket API? I think it's a Berkeley one. Berkeley, I didn't know how to spell that. Even though it's like part of the more or less standardized API, these are also the the syscalls, right? So Linux syscalls. So let's actually Google up Linux syscalls. So where is the table of the Linux syscalls? Here it is. So probably also want to credit that too. I'm going to put that in the description for anyone who's interested. Linux syscalls, right? So that's what we're going to be using. Let's find le socket. As you can see, here is the syscall, right? And as here it accepts 3 arguments, which is the main, the type, and the protocol, right? So, and this is probably what we need to call first. So that means I have to do something like, let me put this thing in here. Maybe I'm gonna even split my my screen. Isn't that fancy? I think it's pretty fancy. So we're gonna have AFINet, then sock stream, then 0, and we're gonna call socket, right? So, and that is supposed to create the new socket, right? So, and since we have let bindings, I can actually automatically bind that thing into a file descriptor and instantly check if it was successful or not, right? And if fd is less than 0, we have to throw some sort of an error. In fact, the problem with this let thingy is that it will remove the file descriptor from this stack. So maybe I want to actually peek into that, but maybe not, we'll see. In any case, if it's less than 0, what I have to do, I have to print an error, right? So I have to say something like error could not create TCP socket, right? I could not create a TCP socket. I'm going to print that to standard error, and I'm going to exit with a non-zero exit code. All right, so after that, what I need to do, I suppose here I'm going to just close the socket right away, and I'm going to drop the result of the close. So let's try to compile this specific example first, right? So just to see how it's going to go. So first of all, we don't have a AFINet, right? So it literally does not exist in our language, and I don't know its value, right? So the usual thing I do, I steal those values from the standard C library, right? So great artists always steal, am I right? So what I'm gonna do in here is just I'm gonna go into the socket documentation, because I need all of these headers, right? I need all of those juicy headers that I want to include in here, because those headers contain all of the definitions that I care about. Right, so I'm gonna do something like that. And in here, I'm going to do the following thing, right? I'm going to print AFINet, and it's going to be equal to that. In fact, I can right away print port, so I can copy paste the output, right? So I'm going to do something like this, and this is going to be AFINet. So the other thing we also need in here is probably sock stream, right? Sock stream and sock stream. So the next thing I want to do is just like compile this and test stuff, right? And let's include the IO stuff and also automatically run just to reveal all of the values of these constants. There we go. Super easy. Super easy, super peasy. That sounds funny. Anyway, so let's try to recompile this example. So it's going to be this http.port. And we don't know a socket function, right? So we do have a constant for that syscall in here, so I'm pretty sure. So it's a sys socket, right? So we just need to create a wrapper for that entire thing. So it's going to be a procedure that is socket, and according to the documentation, it accepts 3 integers, right? So we're going to say it accepts 3 integers, and since it's a syscall, it returns an integer as a, you know, the error code or something. And in here, we're going to call basically sys sock, syssocket, syscall accepts 3, so syscall 3, and it automatically returns everything. So this is basically what I need to do. And since it's such a lightweight wrapper, we're gonna make it inlined, right? So we're gonna make it inlined in here. There we go. So let me try to compile this entire thing, and it didn't complain, surprisingly, because I didn't even run it. So let's do the following thing. Let's do the following thing. I'm gonna just print OK, right, in case we didn't hit this branch, right? And that way we'll know that we successfully created the socket. In fact, I'm gonna say that out loud. Successfully created a socket, And we can also print the value of that socket, because why not? I'm going to duplicate it on the stack, and I'm going to print it as as a number, and then I'm going to print the new line in here. So if I try to compile it, everything's fine, and let's try to run it, and it could not create a TCP socket. So we couldn't do that apparently, which is really interesting. And I know why. Because according to our language, the arguments of the syscalls are accepted in an opposite order. So the first argument is actually here, the second one is here, and the last one is here. And this is due to the language, using reverse Polish notation, right? So we kind of try to follow the reverse Polish notation, and that's why the first argument of the syscall is that one, and then this is the second one, and this is the third one. If you never heard about reverse Polish notation, I would recommend you to check it out on the Wikipedia if you are in fact interested in this kind of stuff. Alright, so I'm gonna also put that in the description for anyone who's watching on YouTube. Reverse Polish notation. Right, there we go. So I think we got a couple of subs. Zero Nal Carnival, thank you so much for tier 1 for 2 months. Thank you, and welcome to our Epic Port Club. How about that? So let's go. Hopefully after that we'll be able to successfully create a socket, and we did. We successfully created socket 5. So that's just the number of the socket, that's just the file descriptor. I wonder if I can create it the second time. So yeah, we're already halfway to our goal. We already managed to create a socket in a language, in our own language. How about that? Isn't that cool? I think it's pretty fucking cool. Holy fucking shit. So by the way, since I'm duping the FD in here, does it really make sense to do it like that? You know what, I think I'm gonna do it like this. This language is starting to have too many ways to do the same thing, so I'm starting to have like a choice paralysis. Is that how it's called? Choice paralysis? Probably. Right, cool. So after that, what we need to do, we need to bind that socket to a particular address, and this is where it gets very, very interesting. Right, because when we bind something, we have to provide the socket, the file descriptor, and then point it to a structure that describes the address. Right, and then the size of that structure. So I wonder if the syscalls in Linux actually work the same way. So if I do bind, where is the bind? So it accepts, so it accepts the file descriptor, the pointer to the structure, and probably the size of the structure. So it's pretty much the same way. So the difficulty is going to be actually getting the definition of that structure. Right, but since we only care about like scene family, scene address, S address, or something like that, we may only like get offsets to these specific fields and just like store them and use them in a language. Also, I'm not sure what exactly H2NL does, so this one is also going to be very interesting. All right, so let me go back to C just to explore this entire thing. Right, let's go back to C. So we're using a structure called sock address in, right? So this is a sock address in. Magic works. Thank you so much for the Rich Prime subscription. Thank you. Your first subscription, by the way, and welcome to our Epic Port Club. How about that? Isn't that epic? I think it's pretty fucking epic, mate. So this one is basically struct sock address in and server address. Okay, maybe it doesn't really matter, because what I can do is essentially just print the size of this of sock address in. So let's do something like that, size of sock addr in, and in here we're gonna have something like this. So this is the end, size of struct sock addr in. Okay, so let's take a look at what is the value that we're trying to get from here. So let's take a look at the value. So we don't have sock addr in, which is rather sus. This is probably because we have to include more of these headers. So let me actually like copy paste this entire stuff in here. Right, so I'm gonna copy paste it like that, and let me see. So it's 16. It's actually really small. What the fuck? It's like two 64-bit numbers. That is a very small structure. I didn't expect that, in fact. Okay, so next thing I want to do, I want to know the offset of scene family. Right, so let me do the following thing. I definitely expected that structure to be a little bit bigger. So this one is something like scene, maybe sock addr in. This one's gonna be something like that. Scene family. So for those who doesn't understand what I'm doing, I'm essentially hacking the C. Right. I'm figuring out the sizes of the structures and the offset within the fields of the structure so I can port them to my own language and use them in my own language. Right. I could have looked up the definitions of the structures, but even though I could, it wouldn't give me the full information. I need precise numbers. I need precise number in bytes. What's the size of the structure? What's the offset of that field? And so on and so forth. Right, so that's essentially what I'm doing. So, and in C, it's relatively easy. You can literally say size of that specific structure. And on top of that, in C, you have things like offset of, where you can specify the name of the structure and then the field, and it will tell you the offset within the structure to that field, right? It's not family, yeah, it is family with a single L. So that's what I'm doing, right? And then I'm gonna use these offsets within my language, right? Thank you so much, Usitan, for tier 1 subscription, for 4 months of tier 1 subscription. Thank you, thank you, thank you. And Ganovin Banana, thank you so much for 18 months of tier 1 subscription. I really appreciate that as well. Thank you, thank you, thank you. All right, so let me see what we're gonna get. All right, so yep. So let's take a look at the offset of this thing, and of course there is no yeah. So if I go to comma, implicit declaration of offset of. I forgot where offset of is defined. So C offset of. Do I have to say that I'm using like the latest standard of C or something like that? Or maybe I have to include std_def. Maybe that's what I have to do. So let's actually bring all of these standard things in here. And these are not standard things. Well, I mean, they kind of standard, but they belong to a different standard, right? So, yeah. So essentially, these are standard C functions, and these are POSIX functions, which is a separate standard. All right, so std_def.h, and I wonder if it's gonna work, and there we go. So literally the scene family field is at the beginning of the structure, so the offset is 0. Okay, that's pretty cool. Another thing I'm interested in is what's the size of that thing, right? So is that a 64-bit integer, or maybe it's a 32-bit integer? This is actually very important. Right, so I'm gonna say size of this entire thing, and we're literally gonna get, I wonder if I can, I think I'll have to create the instance of that structure first, and only then I'll be able to take the size of it, which is kind of weird, but yeah. So probably I'll have to do something like this, right? Maybe even zero initialize this entire stuff. Maybe even something like that. And then I'm gonna say, give me the scene family, right? Give me the scene family. Is it gonna work? Okay, 2 bytes. It's a 16-bit number. Wow, that's why it's so small, because all of these fields are so small. Right, it's like 2 bytes, 1 byte, and okay, so that's very important actually. Okay, that is pretty cool. That is pretty cool. Okay, Nate Rocks, thank you so much for Twitch Prime subscription. Thank you, thank you, thank you, and welcome to our epic Upwork Club. Okay. So let me see. So the rest of this stuff, So this one is actually like a nested structure, right? So which is kind of but yeah. I suppose the next thing I want to check the scene port, right? So let's take a look at the scene port. sceneport. Let me take a look. And sceneport is also 2 bytes offset, right? So this is the offset, and the size of that thing is 16 bytes. So I'm not sure about the scene address. Let's bring the scene address into the scene. Though I would like to separate those things with the new lines. Oh, that is weird. Okay, so we're gonna do something like this, right? So cool. So we can see everything more or less clearly. Scene family and scene address. So this one is ADDR. Cool. And scene ADDR is, as you can see, is a structure of 4. What about not only scene ADDR, but more of a because it's going to be an offset within another structure, right? It's going to be an offset within another structure, so it's not particularly useful for me in here. So I can take a look at the size of S address. Right, so this is a S address, and the size of this thing... Ooh! This one is very surprising, what the fuck? So it's a S address. Huh. And the size of S address is the same as a scene address. So I presume scene address, yeah, it's literally 4. I presume this is because this thing is an enumeration. That's my hypothesis. It's literally enumeration, and you will be able to basically look at it as like different types. Maybe because of that, like, we don't really need to worry about, you know, yeah, about like nested structure or anything like that. We can treat this as a 32-bit number, right? But I kind of want to confirm that. I kind of want to confirm that this thing is not enumeration, union. I'm sorry, not enumeration, union. So, and to do that, I'll need to look up the definition of this thing. So I wonder where it is defined. So let's go into the user include. Right, and I'm gonna just like grep rn, and there we go. So we're already getting something from libr. Libr is actually a very interesting thing. Libr is apparently a library for Radari 2, which is a sort of like a reverse engineering tool. Radari 2. And I installed it once, and every time I search anything related to POSIX, there's always a definition in that libr there, for whatever reason, which is really, really strange. So I suppose maybe Radari 2 has its own like implementation of POSIX or something like that for like in this library libr. I have no idea, but yeah. So this is a Radari 2 if anyone is interested. So you can find this thing in here. Maybe one day I'm gonna do a stream where I reverse engineer something with Radari 2. I'm not a big InfoSec person. In fact, I know nothing about information security. But I might try to do something. Maybe solve a couple of crackmes or something like that. Because I know assembly, right? So that means my knowledge is enough to do simple challenges related to binary exploitations. Could be interesting. So thank you so much, Duralabs, for tier 1 subscription. Thank you, and welcome to our Epic Porth Club. How about that? Alrighty, so what I want to do, I want to just find the definition of this thing. Right, so here is this stuff, and this is a structure. Oh, this one is interesting. It's a structure... Very funny. It's a structure with a single field. Right, it's a structure with a single field, and that field is this thing, and that is just like 32-bit integer. So very interesting. So maybe I don't have to worry about this structure, so I can just treat this entire thing as like a single structure with you know, yeah, so basically like 3-field structure. So this address, 32 bits, scene port, and also there should be some sort of scene family or something like that. There's also padding, some sort of a padding, but that's fine. All right, so I think I have enough information for all of this stuff. So scene address So let me recompile the entire stuff. So this one is GCC. Okay, cool. So that's basically the definition, and I can go ahead and copy paste this entire stuff into my Porth code, right? So, and this is how I still see code into my Porth applications, right? So that's how I do that, literally. So this is the size of the entire structure. These are different fields. I might as well actually like move this stuff in here. So, I'm not sure if I really need the sizes of the fields, right? Because I can't use them to check anything at compile time anyway, but it's just like nice to have them somewhere here. So maybe I'm gonna even do it like that. Right, so here are the offsets and here are the rest of the stuff. So though it's, yeah, so this doesn't add up, we're like literally using half of the entire structure, right? So this is a half of the entire structure anyway. And this is because this is a sock address. So this is not really the size. This is not really the size of the sock address in, it's the size of the sock address, and sock address in is just a specific implementation of more abstract thing as sock address. So there is like a little bit of the inheritance, OOP style inheritance in the socket API, right? So you have abstract interface sock address, and you have like things that inherited like sock address in and some other things, right? So yeah. That's essentially what we have. Cool. All right. So let me recompile the HTTP. It seems to be compiling, which is nice. And I'm gonna go back to my tutorial. Literally following tutorial, by the way. Literally following tutorial. And I'm going to allocate the sock address structure on this stack. So I'm gonna have something like memory. This is going to be serve address size of sock address, right? There we go. So here we basically created the socket, we checked that it didn't fail, and now probably the first thing we want to do, we want to clean up the entire structure, right? Because if you allocate some memory on the stack in a procedure, it is not guaranteed to be zero initialized. So you literally have to zero initialize it yourself. So as far as I know, we have a special function memset, but I don't remember in which order it accepts the arguments. So we have to look it up. Memset, so it accepts the size first, size of sock address, right? So this is the sock address, then the value of the bytes, this is going to be 0, and then serve address, and it also returns the pointer to serve address, which I don't care, so I can just drop that. Okay, so it's 0 initialized. Next thing I need to do, I need to take the serve address and find the offset to the scene family, right? So this is going to be sock address in scene family, and so by using this thing, I'm pushing the pointer to that structure on the data stack, then I'm pushing the offset for that specific field, and I'm adding that offset to that specific pointer. That way I'm getting the pointer to the scene family, right? And the next thing I want to do, I want to in fact save AFINET into that pointer, but we have to keep in mind that scene family is 16 bytes, like, right, 16 bits, so 2 bytes. To save it as 16 bits, we have a special intrinsic called exclamation mark 16. So essentially it takes the pointer on the stack and the value, and it saves that value into that pointer as a 16-bit value. Right, and we have different intrinsic that save as different types. You can use like 8 bits, 16 bits, 32 bits, or 64 bits, right? So we have to be a little bit careful here because it's 16 bits, right? So we are interacting with the C code, and that's why we need this level of control. This level of control. Okay, so the next thing is going to be setting the S address, and we're setting it using H2L, and I have no idea what the fuck this function does. Yay! So what is in address any? In address any, is it defined anywhere here? So apparently it's some sort of a built-in constant. Let's go back to the main C code. Let's go back to the main C code. So maybe I'm gonna just okay, I'm gonna just take that. I want to regroup everything as I did in my porth code. So to do that, I need to put sizes in here. Right, so this is gonna be a GCC like that. Okay, cool. So this is that, and this is that. Now, printf const in address any. In address any, and let's print the value of this entire thing. Right. In address any. So let me see what's that. What's that? So it's a value 0. Nice. Nice to know that it's 0. Cool. And what about h2l? Let me take a look at the man of this function. h2l. Ooh. There's no... Okay. h2l, h2l. So what if I try to print the value of h2l? Let me guess. Is it going to be 0? Is it going to be 0? Right, so basically something about... It's probably something about the byte order, right? So it's something about byte order. Oh, I think I made a mistake. It's h2nl, right? So h2nl. Yeah, converts between the network byte order. Okay, so there's not... And since this thing is any, right, so it's 0, it's going to be 0 anyway. But that essentially means that we're, I suppose, accepting the connections from anyone, right? So this is basically any. Is there any way for me to, like, have a specific address, like a local host or something like that? That would be Pogue, but maybe not. Maybe I don't care. So, yeah. So essentially, if I just try to print this entire thing, right, if I just try to print this entire thing, h and l, it's going to be 0, and I really don't have to care about that, right? So I really don't have to care. So... How can I just take IP address from a string and convert it to to the S address? What's the function for that? Okay, so let me see. S address localhost. Understanding any for socket programming. INET address. Okay, so that's what I wanted. That's literally what I wanted. Let me take a look at the INET address. It's gonna be man. Oh my god, Emacs. Why don't you remember what I put in the clipboard? INET address. INET address. INET address. So it takes this thing and returns you that stuff. So you know what I want to see? I want to confirm. So in address T is a 32-bit number, 4 bytes. If I put the IP address as usual, does that mean that each individual octet, I think they're called octets, is going to be in the byte of the 32-bit integer? Oh, it makes sense. But I never thought about it, actually. Yeah. I always just like call to this function without thinking what exactly this function does. But I suppose it just like parses the string, takes each individual octet, and puts that octet into the corresponding bytes. Which raises the question, why do I need this function? I could just do that manually. Just like one of the things that I just followed tutorial and never put any thought into, just like copy pasted, and yeah, it's like I don't need this function, I just can, yeah, but we need to confirm that, right? We need to actually confirm that. So I'm gonna just like take this entire stuff. And it's gonna be 127.0.0.1, and that should give me some sort of a thing, right? And then I can say print it as the hexadecimal number, and I suppose it's gonna be in a network order. That means that the first byte is gonna be this byte. These bytes. Okay. Hopefully, we'll see. If it is simple like that, I might actually, you know, easily implement all of this. All right. No, it is slightly different. It's in a different order, actually. Huh. Implicit declaration of function init address, and this is what it printed. To localhost only, syntax should be like this. Okay. In address none. And in fact, I think I can just use that value literally right in the code. But I don't have a hexadecimal numbers, right? So I don't have a hexadecimal, so I'll have to do something. I have to do something about that. So what if I do H to an L? It will just literally reverse this entire thing, right? So it reverses the bytes, but this is probably not what I want, right? So for this specific thing, right? Init ADDR. Let me find. Converts the internet host address from a number into binary data in a network order. So it already uses the network order. Right, already uses the network order, and I can just grab this entire thing. Since our language does not support hexadecimal numbers, right, it doesn't support hexadecimal numbers, we'll have to use this number. I like how many hacks you need to use in that language to get anything. That I absolutely love it. Right? You don't have a hexadecimal numbers, like you just have to use this number now. It's beautiful. I absolutely love that. Okay, so but we're gonna support hexadecimal numbers in the future. Don't worry about that. It's just like right now we don't support them, but in the future, of course, we're gonna have them. Is there something like? So there is a in ADDR any, right? There is such thing as a in ADDR any. Is there something like ADDR local, right? So there is no such thing. Okay, I'm gonna invent that. So this thing is gonna be called in ADDR local, and I invented that. So I'm gonna put a node in here. This is not standard. I invented this constant as an opposite to in ADDR any, because it does make sense. If we have in ADDR any, why don't we have an ADDR local, right? So I can just quickly say, okay, only local connections, any connections and stuff like that. I think it makes sense. Like I'm actually quite surprised why this constant is not like a standard constant. I don't understand. Anyways. So let's go back. Let's go back to our tutorial. So we saved this thing. So in the next thing we need to do is that stuff. In ADDR local, right? SRV address socket sock ADDR in scene address pointer plus, but we have to save this as a 32-bit number, right? It's a 32-bit number. So we might as well also do something like this, just to align those things more or less properly. And the next thing is going to be a port. All right, so here we have a port. And oh yeah, we have to ensure probably some sort of like stuff in here. So yeah, so we already have a port 6969. Port. This one is sceneport. But how are we gonna do H-tone S? H-tone S. Right, it's basically different sizes of this stuff. You know what? We're using 6969, right? So it's... No, it's not 2 bytes, fuck. Is it 2 bytes? It's not 2 bytes. I was just thinking that 69, a single 69 is gonna be like a 1 byte, but it's not 1 byte. You know what? I have an idea, actually. I have an idea. Though I can just implement that, but first let me confirm that. Let me confirm all of that stuff. Yeah, if it was 0x6969, that would make sense, but it's not like 0x. Unfortunately, it is not. It is not. So let me see. So if I just print 6969, right? So this is how I get that. But if I print it like so, right? So h tons 6969. So this is what I'll get, right? Yeah. So this is the port that I'll have to use in here. So this is the port. So let's actually implement our own h tons. I think that makes sense. So I'm gonna go into port and just implement my own h tons. That should be cool. So in here, I'm gonna accept an integer and I'm gonna just return an integer, right? So in. And it should be as simple as just taking the number, right? So we have to take its lower byte. So essentially it's x 256 and I do AND, right? So this is basically its lower byte. Right, then I'm gonna do x and I have to shift it by 8 bytes to the right. Shift to the right and then do 256 AND. There we go. So something like this. So this is the first one and right, this is the first byte and this is the second byte. Which means that now I need to shift this one to the left by 8. Right, I'm shifting all of that by 8. And then I can just OR them together. Right, so that's basically how would you implement h tons, right? So you take the first byte, you move it to the left, then you take that one, move it to the right, and you basically swap 2 bytes. Right, you just literally swap 2 bytes. So let's actually do the following thing. So it's gonna be proc in, and in here I'm gonna just do 6969 put u, new line puts, right? So if I try to run porth.com http.porth, right? So it prints 6969. And if I do that, but h2s, htons it will print 14619, and that's, I think, exactly was the value from the C program. Yes, it's exactly the value from the C program. So we implemented our own htons, right? Is it swapping bytes or bits? I think it's swapping bytes, because like yeah, it worked. I think I did everything correctly, right? Because it is called network byte order, right? It is called network byte order. So yeah, and by the way, all of that is going to go into the standard library. So the next time I'll need to do something related to the network and Porth, I'll have all of that available in there. Plus, I'm going to have an example on how to open the server socket, right? So all of that is not going to waste. Like I'm actually like sort of building up documentation, right? Because I believe that the pieces of code and examples are the best documentation, right? Because you can copy paste them and just like adapt them to your case. So yeah, so that's basically it. Okay, so here's the port, and I need to do something like htons, right? So I'm converting that to the network byte order, and then I'm saving it like that. Cool. So yeah, that is basically it. I hope I set up everything correctly. I set up everything correctly. So this is a server address. And the next thing we need to do, we just need to call the bind operation. Okay, so let me see. So main procedure is not provided. So here is main. So successfully created this socket. Okay. All right, so we need to call bind. The first thing we need to provide the size of the sock address, right? So here is the size of the sock address. Next, we have to provide the pointer to the structure that we just initialized, right? As you can see, we zero initialized it and we set all of these fields appropriately. Right, so let's put it like this. So this is a server address. And the last thing we need to provide the socket file descriptor. So, and then we have to call bind. Excuse me. Now, I need to do what? I need to check the result. If the result not equal to 0, I suppose it's going to be less than 0. That means we encountered an error. Encountered an error. So could not bind the socket, right, for whatever reason, and we're gonna exit with non-zero exit code. Right, so, but we don't have a bind syscall, right, so we'll also need to make a wrapper, just like for the socket. Bind, and what do we accept in here? For the bind, we accept integer pointer integer, right, integer pointer integer, and return an integer. Then sys bind syscall 3, and then just return this entire thing. All right, there we go. I successfully created the socket, and it didn't really say anything about binding the socket, but I'm going to presume that it did that successfully. But on top of that, it didn't really close anything appropriately. No, it actually closed everything appropriately, right? So it closed the socket at the end of this entire stuff. Right, so maybe I'm gonna put this entire stuff here, right? Successfully created a socket. Successfully bound the socket to port, and then we can print the port. So this is gonna be puts. I'm gonna take the port, put u, and then this is going to be the new line, puts, and we can also align everything by put, right, like so, and here as well. Align everything by put, and if I try to run this entire thing, okay, successfully created a socket, successfully bound the socket at, to port 6969. Cool. That is very, very cool. The next thing I suppose we have to do, we have to listen to the socket, right? So, yes. Now server is ready to listen and verification, whatever is that supposed to fucking mean. All right. Server listening. Okay, so let's go ahead and do that. So what is 5, by the way? Is that a like amount of connections in a queue or something? So it's a backlog. Defines the maximum length to which the queue of pending connection socket may grow. Is that something that is available in the syscalls, by the way? Let me take a look. So bind, no, not bind, but listen. Okay, so listen accepts, yeah, it accepts 2 integers. Okay, this is actually perfect. So it accepts 2 integers, and that is perfect. So this one is going to be 5, and then the FD, and then listen. And this one could be less than 0, right? And if it's less than 0, we're gonna say error. Could not start listening. Could not start listening. I'm gonna put eputs, and then exit with non-zero exit code. And here we're gonna say successfully started listening. I suppose successfully started listening. Right, we don't have to say in the port, right? We already said that in the previous operation. There's no listen, super easy to add. Inline proc listen, integer, integer, return integer. In sys listen, but this time is syscall 2, right? Because it accepts 2 arguments in here. There we go. So we have some unhandled data, which is rather strange. Where do we have unhandled data? Who put... Oh, okay. Yeah, I forgot to remove this code. Yeah. Cool. So successfully started listening, and I can do that several times. So none of the syscalls actually returned incorrected, like some sort of error code, which is nice, right? So far so good. So far so good. And then we should start accepting the incoming connections, right? So in here we're using something like CLI. And the length or something like that, and I don't know what is a CLI. Apparently it's the address of the client, and it's the same structure as a server address, which is perfect because we already know the definition of the socket address structure, so we can just like literally allocate the second one, right? So memory CLI address, right? So there's a server address and there is a client address. Both of them are size of sock address. There we go. Cool. And then we have a length, which is, for some reason I have to pass the length of this structure as a pointer, which raises a question, why? Not sure. So this one is accept. All right, so accept. Oh shit. Okay, so there's accept 4 and some other stuff. I suppose maybe accept is already like old syscall because there's accept 4. Right, so probably you're supposed to use one of these things. And here it accepts more things, but we're gonna use like the old syscall right now. I'm gonna look into what's the difference between syscall accept and accept 4. Is there accept 3 or something like that? No, there's only accept 4. I suppose it indicates the amount of arguments you have, like wait for, right? There's a syscall wait for, but for now I'm gonna use accept. So here we have, yeah, we have a pointer and that one and that one. Which means like it's really strange, but if it wants to have this thing, sure, I'm gonna give it to it. So it's the size, and the question is, what's that size? Is that a 32-bit? Yeah, it's int, which means I presume it's a 32-bit integer. I suppose it is, right? There is no other explanation because on 32-bit architecture, right, int is 32-bit, right? So let me take a look at this thing. Soclen. Okay, so they're referring to something that is called soclen, not just integer, but soclen. Let me go to main.c, right? Because we have to be super careful, right? So there's no compiler that will help us with all of that. We'll have to like do all of this math ourselves. Right, nothing is going to be converted. Okay, 4 bytes. So that means it's going to be just like a 4-byte integer. Where is my HTTP? So size of... Do we have U32? I don't remember. So we probably had... I remember we had something in here. Size of... Yeah, we do have a size U32. Okay, so I created such constant in here. Cool. Cool. So first I'm gonna have CLI len, right? So CLI len. Then the pointer to the CLI address, right? So this is that. And then the FD, and then I'm gonna do accept, right? So I'm doing accept, and this thing is supposed to return the connection file descriptor. So this is gonna be con FD, right? We've got a con FD, and if con FD is less than 0, right? If it's less than 0, we're gonna say, yeah, we can just say server accept failed. Error server accept failed, eputs, and just exit in here. Otherwise, we're gonna say that the server accepted the client. Server accepted the client. And then puts. That will automatically remove that, and I suppose we'll have to close that con fd. Do we close that at some point? Close con. We never close it, surprisingly, but I think we have to close it. I have a feeling that you have to close it just in case. Well, let's close it just in case. Close, drop. Right. I think it makes sense to do that. Cool. Very cool. So can I now run the entire thing? And we don't have accept, which is fine. It's totally fine. Don't worry about that. Inline proc. So the first one is a pointer integer, and we return an integer. And in here, sys accept syscall 3, and there we go. Cool. And this thing is listening to a particular connection. Right. So the application has blocked. What if I now try to do telnet 127.0.0.1.69.69? First try, mother flipper. Easy. Wow. I'm actually surprised it worked. Like, I literally hacked all of that shit together from C. Like, I took the constants from C, offsets from C, and I just like put it together, and it's just like, yeah, works in Perl. So we can accept the connection, apparently. So, wow. Okay. So one of the things we can do now, we can basically return something to the client, right? Some sort of a response. So HTTP response. So we've got a sub from Tulf. Thank you so much for 6 months of tier 1 subscription. Thank you, thank you, thank you. I'm really glad that you like the stream. Thank you, thank you, thank you. Alrighty, alrighty. Very, very cool. I'm actually quite surprised. What the fuck? So we can just use this confd to answer something to the client. That's literally what we can do. So if server they accepted the connection, we can just say something like hello world, hello world. And we're gonna send that to the confd, and we can literally use fputs function because fputs accepts the Linux file descriptor. That's literally what it does, and it also ignores the return code, by the way. But that's fine. That's fine for now. So now let me try to run the entire thing. All right. So we're waiting for the client. We're waiting for the client, and I'm going to do telnet localhost 6969, and it said hello world. We literally received hello world from a port code, right? So we not only like answered the connection, we not only accepted the TCP connection, we also sent something back. And when you start sending something back, you already like 99.999% to a HTTP server, because a basic HTTP 1.1 server is basically that. It's a program that sends you some text over TCP socket. That's literally it. I'm not talking about like more sophisticated HTTP protocols like HTTP 2 or HTTP 3 and stuff like that. We're doing some basic stuff here. We're doing some Web 1.0 right now. So yeah, all right. And this is how much code you need that. And that code doesn't even link with the C library. This is without using C library, by the way. Right. So not linking with C, because whatever we have in here, like the HTTP executable that we got in here, right? So if you take a look at the file, it's a statically linked file, and if you take a look at what libraries it links with through LDD, it doesn't link with anything. It's like, yeah, it's a self-contained thing that will probably work on any other Linux distribution with pretty much the same kernel, right? It's actually a very old kernel. I should probably upgrade, but it's a Debian anyway, so who cares? So yeah, anyways. So we need to send something back that is parsable by a browser. I don't remember what you're supposed to answer. I literally don't remember. So Enjoyishka, thank you so much for 3 months of tier 1 subscription. Thank you, thank you, thank you, and welcome back to our epic port club. Probably need to make a small break because I'm already kind of a little bit tired. So yeah, isn't that Paug? Isn't that Paug? I think it's pretty fucking Paug. So it's not enough to just return HTML. What we have to return, we have to return HTTP response. HTTP 1.1 response example. So responses, tutorials, okay. Just show me an example. Okay, so this is a pretty good example, I would say, right? So it even uses content length. Sometimes it works without the content length, sometimes it doesn't work without the content length. So I'm not sure. Well, like, we're gonna try without the content length first, and then we'll see. So I'm gonna put that in the description, of course, because I'm gonna be crediting all of these things. Description. So what's that? Tutorial. So HTTP response. As much as I dislike these SEO parasiting websites, like Tutorials Point or Geeks for Geeks, I'm using them, right? And everyone is using them. It's kind of funny, like how everyone hates them, right? Because they're always at the top of Google, but everyone uses them. It's just like, yeah, there's no need to deny that. Everyone's fucking using them. So anyway, that's why I'm crediting it here. Okay. So what we're gonna return in here is this. So I don't think I'm gonna provide the date. I am gonna provide the server. Right, I am gonna provide the server. Oh, and by the way, we have to separate them with /r/n according to the RFC, as far as I know, right? So what we're gonna put in server here. So we're gonna say HTTP port. that's the server. It's the HTTP port. HTTP port. Jesus Christ. So I'm not sure about the content length. Right. So I'm gonna just like put it in here, and I'm gonna comment it out. So the content type is definitely gonna be the text HTML, and connection closed. I don't remember what connection closed means actually. HTTP header connection. So what does it do? Connection general header controls whether the network connection stays open after the current transaction finishes. Okay, so I can just like use closed. Don't keep it opened, because why would you? Why would you? And recently we implemented /r, which is pretty exciting, not gonna lie. So confd fputs, and we're gonna just be sending all of that stuff in here. Right. So /r/n confd fputs. And then here we can start like sending something back. Let's send h1 and say hello from HTTP port. Hello from HTTP port. And this is going to be just like a new line. Right. So, and now I'm going to do a little bit of a Emacs magic. Boom. Look, Jesus fucking Christ. Didn't really expect it to be so scuffed, but what I wanted to do in here is just this, right? So this is how we respond to the client. So this is what we're gonna send to the client. All right, so, and let me try to restart the entire thing. We're waiting for the connection, and I'm gonna do localhost 6969. Easy, GG, easy. Easy, from complete freaking scratch, working with the browser. All right, thanks everyone for watching. That was a nice stream. All right, I didn't even know what to do next, to be fair. The main problem with this server is that it actually like exits after serving one single connection. It would be nice if it actually continues serving the connections and stuff like that. I'm surprised that it worked without the content length, because I remember when I was experimenting with this exact idea in other languages long time ago, I remember that I had trouble you know, getting it to work in a browser without the content length. But now it works without the content length. Maybe because I said close the connection, or maybe I'm closing the connection in here. Maybe that's something, has something to do with that. If I actually remove the connection here, I don't know why I care about this so much, but it's just like something that bothered me. No, it's fine, it works fine. I suppose Port is a superior language than whatever I used to use before. Okay, so that's pretty poug. That's pretty poug. The thing we can do in here, I suppose, is just like organize the loop. Right, we can organize the loop in which we are accepting everything and like keep serving this entire stuff, right? Keep serving this entire stuff. The question is like, we need to be able to exit the application gracefully. Otherwise, we're gonna have a situation that the port is bound, and we won't be able to bind it again, so we'll have to switch to something else. Which brings me to a very interesting question, like how can we do that? It would be nice to be able to parse the client query, if you know what I mean, like parse the client query, and then parse the you know, the URL and different commands. And for instance, I want to be able to do something like /quit, right? And that will quit the web server. Right, I know there's no authentication or anything like that, but we just started to write this thing like 1 hour ago from complete scratch. Of course, there's nothing in here, but I just want to have something to interact, to be able to interact with the web server, right? With English is hard. But yeah, so it would be nice to be able to like parse this entire thing. Control C. Here's the problem with the Control C, right? So it interrupts the execution. So that means it will be interrupted probably somewhere on accept while we're waiting for these things, right? And we won't be able to properly close the socket. So that means we'll have to set up the signal handler, right? So we'll have to capture the sigint signal. Here's the problem. I have no idea how to do that in Porth, honestly. And I'm not even sure if Porth can even do that. Right, because you probably need to give kernel the pointer to the function which you need to call, right? You need to give that thing. So this is the first thing. So that means we have to conform to the basically Linux x86-64 syscall conventions. Not syscall convention, call conventions, just call conventions. So, but here is an interesting thing. Do we have to? We only, because we are being called. We are being called, not we are calling to something. So, shit, probably it's not gonna work well. Okay, so because right now, Porth, if you want to call Porth function, you have to prepare its stack in a certain way, right? And we would expect a kernel to prepare its stack in a certain way. So that means we need to be able to mark a certain procedure as a C procedure that is called by C code, so we don't expect the stack to be prepared in a particular way. So we need like a proper FFI to handle sigint. So I don't think it's an option that I can have right now. Right, we're gonna definitely implement the FFI and stuff like that, right? We'll be able to call C functions and be called from C functions, but not right now. So, and because of that, I can't really handle Control C and sigint, right? So, because the language is incapable of doing that. So, and because of that, I better like just parse whatever I receive from the client. So that's gonna be basically the idea. So should be relatively easy. So I can just allocate the client buffer, right? So this is gonna be client buffer capacity, and let's say we're gonna allocate like 1 kilobyte of the client buffer. So this is gonna be just a memory client buffer capacity, right? So that's cool. So, and server accepted the client, and the first thing we can try to do is essentially just read whatever we got from the server, right? Just read whatever we got from the server. Now, I'm gonna use read. So in here, I'll have to provide the size of the buffer. So it's gonna be client buffer capacity, then the client buffer. So here's the client buffer and the, you know, this thing in here. And here we're gonna have this size, right? So I'm gonna do let size. Let's call it buff size. So, and the buff size can be actually negative, indicating that something went wrong while reading the, you know, the data from the client. So we need to indicate that. So file size can be less than 0. And if it is, we're gonna just say that could not read the client request. I don't know. So that's basically what we're gonna say. Couldn't read the client request. And for now, I'm just gonna go and print whatever we got from the client. So there's gonna be a client buffer. Might as well just call it client buffer size for the consistency. So it's a client buffer. So client buffer size, and then just gonna do puts. So that's all we got. And then we can say something like client says this. So client says this, and this is what we respond to the client, right? So, okay, now let me start the entire thing, and I'm gonna refresh this entire stuff. And as you can see, okay, just a second. Okay. Yeah. Okay, so I don't think I have anything sensitive. I forgot that I actually was running different things on that domain, and that my browser might send some cookies, right? So the only cookie that it has in here is just like this thing. I don't think it has anything super sensitive in here. But this is basically what I got from the browser, right? But I have to be super careful, right? Because I keep forgetting that the browser sends cookies, right? So cookies was a, good idea, am I right? I ran out of water. But in any case, so what I can do in here is essentially get the first line, right? Get the first line and just parse it. Should be relatively straightforward. So the client buffer hopefully is big enough that it will fit everything. I will need to check out on what's the maximum size of the status in here and just allocate buffer big enough for this thing. But for now, it doesn't really matter. So, and here's the cool thing. I can just take the size of the buffer and the pointer to the buffer, and it is a valid port string. It is a valid port string, which means that I can now split and manipulate it as a port string. So as far as I know, in a standard library, I recently implemented a function str chop by delimiter, but this one accepts a pointer to the string. I created a chop by delimiter 2. Because chop by delimiter was so good, I created a sequel, right? So here it accepts the input and the delimiter and returns you 2 strings, right? The prefix that you got and the rest of the string, which you probably want to throw away at this point, but we only care about the prefix. So, okay, this is going to be that. And what I can do in here, I can say, okay, use new line to do str chop by delimiter 2, right? So we're going to be like splitting it like that. And then in here, we're going to have the string, right? So here is the string. And after that, we're going to have the rest of the stuff, which I also want to drop, right? So I'm going to put it like this. And let's say client request puts and as puts, new line puts. Cool. So that's what we have in here, and I'm gonna refresh this entire thing, and it says client request this thing, right? I can refresh this entire stuff, and now, yeah, it couldn't bind. Yeah, nice one. So it happened without me. Is that because I pressed Ctrl-C or something? In any case, I can just do 69, maybe 68, right? So I can rebind it to a different. And what I want to do in here is just like do something like quit. And as you can see here, we have the quit, right? So this is basically the quit. So the next thing I can do is do the rest of this stuff, right? So this is just like the status, right? And then for that specific status, what I can do is split everything by space. But I'll have to do that a couple of times, right? So I'll have to do that a couple of times. So you know what? I can do this kind of thing. So this entire stuff returns 2 strings, 4 values, because string is a size plus a pointer. What I can do, I can basically say, okay, forget the rest of the string, only bring me the prefix that you chopped. And I can do that with a single line with let bindings. So basically it takes these 4 values from the standard library in here. So this is what this function returns. I can say I can take 4 of them. I can bind only the last 2, return last 2, and forget these 2 things. This is what you can do in port, by the way, with let bindings. It is a valid port code. It is absolutely valid. So then I can now chop by a space. Right, I can now chop by a space, which effectively means that I will get this thing and then the rest of the stuff. So in this specific case, I care more about the rest of the stuff. So I'm gonna do actually something like this. Right, there we go. So I'm forgetting the prefix, but I'm getting the rest of the stuff. Then I want to chop it by space yet again, but this time I want to forget the rest of the stuff because I need to bring in the prefix. So in this way I can sort of maneuver and parse exactly the query string. Like I can parse exactly that from the input of the client, and after that I can just like go ahead and print this stuff. So I can do puts. And here I can say client query. Is that called query? I think it's called route, right? Request route, right? So this is a request route. I'm printing it, and then after that I'm printing a new line. Okay, so I'm gonna do something like that. And if I refresh this entire thing, it says request route quit. As you can see, we managed to do that. Right, so I parsed the specific route the user provided in here, just using like a sequence of these operations, right? I've been chopping by delimiter, and I've been forgetting like different things, and it was relatively actually straightforward. Like let bindings make it super convenient to do shit like that, holy fuck. And okay, and after that, once we've got the route, right, once we've got the route, we can dispatch upon that route, and if it's quit, we can just quit the entire application, if that makes any sense. See what I mean? So, isn't that cool? I think it's pretty cool. All right, whatever. So here we parse in the route, right? So here we parse in the route. And now we just need to do what? So let's actually do ns. And this is going to be ns. And if it is quit, right, if it is quit, str equal, right, so what we're going to do, I suppose we can just say true quit boolean, right? So we're going to have a global variable quit, which is responsible for this kind of thing. Right, otherwise, ns. If it's anything else, we can just put else in here. We're gonna be always serving this hello world. Right. So we're gonna be always serving that. So when we're quitting, actually, before completely quitting, I think we could have at least said something to the user, something like shutting down the server, right? So we can do that. I don't think it's a bad idea. So here we can say something like shutting down the server, right? Shutting down the server. And here might as well just do something like align con. Okay, cool. So I just want everything to be aligned. Cool. So let's actually have the global quit variable somewhere here, memory quit, and it's a size of boolean, right? But we also have to initialize it. False quit boolean. Okay, so we need to start the loop. We need to start the loop while quit, while we're not quitting, right? We're going to be accepting the connections from the clients. All right. We're accepting the connections from the clients. Right. And we're also routing, depending on whatever route you put in there. Right. So we're also routing everything. It's actually really cool that this code parses the route from the HTTP request. This is so fucking cool. It is very fucking surprising. But it's so easy with LED bindings, which further confirms that LED bindings were a very good idea. Very, very good idea, because they're so powerful. My god. Okay, so let me recompile the entire thing, and it seems to be compiling, so I'm gonna refresh this thing. It says hello port, and it keep answering, so this entire thing. Now, chat, look, I'm going to here, and I'm pressing /quit. Right, look, I'm doing /quit, and I'm going to here, and it says shutting down the server, and it shut down. So we have routing. Shit is too easy, holy fuck. So we have routing. Of course, it's nowhere near being like a proper, like standard compliant server, right? But it's just like, yeah, you have routing and shit. So, oh. Yo, the fuck? The fuck is this shit? So, but we need to have like a proper, like a URL parser, right? So because URL is a separate sort of RFC, right? It's not just like separating by slashes. You also need to parse everything after the question mark and stuff like that. But yeah, it's very, very cool. Very, very cool. Very, very cool. Very, very, very cool. So I don't know, let me maybe start cleaning everything up and putting these things into the standard library of some sort, right? The other thing we can do, we could try to serve specific files and basically make our server very unsafe, because that's where majority of the vulnerabilities in web servers come from, right? So you'll be able to go like ///etc passwd, right? So let's enable that feature. We can try to do something like that, right? And we can use a syscall called sendFile to actually just basically send a whole file to the server. Right, this is actually a pretty cool syscall, right? So we have an output file descriptor. You can open a file and you can use it as infd file descriptor, and it, like in the kernel mode, it will send the whole file through the socket, right? So making it super fast. Also, there's a bunch of offsets. Probably you have to do that in a loop, right? So I'm not quite sure. We can try to do that, but I'm not sure if I want to do it right now. So, okay, so we have a sub, RTNA. Thank you so much for 3 months of tier 1 subscription. Thank you, and welcome to our epic port club. Port. Okay, go. So, what else do you need in a HTTP server? Probably you want to have a dynamic page. How about that? This is very important. Do you guys remember? Who's young, who's old enough to actually remember these websites, this magical website when you come into them and they will tell you how many times that page was requested. So they had this little counter like at the bottom saying how many times that page was requested. Wasn't that epic? It's a Web 1.0 technology. Who remembers Web 1.0? Let's fucking replicate that shit. Holy fuck. Because that requires maintaining the state, and our language is capable of maintaining the state between the requests. So let's actually do something about that. Okay. So let's have something like request count, right? So here's the request count, size of integer, right? So this is request count. So, and once we answer hello from HTTP port, we can say something like p. It's kind of difficult to actually see what's going on, so let's put it like this. p/n. This page was requested. So, and then we can say something like request count. Read it as an integer, right? Something like this. This amount of times, right? So we have to do conf_fd fputs, then confd fput u, right? And this one is going to be confd fputs. You don't even need any templating. Here is your template essentially, right? So that's what you can do. And I suppose we can just increment the request count. We can increment the request count right before generating the response, right? And every time we create this page, it will increment it and just like send this thing back. All right. So let me maybe actually go back to here, right? So we don't have anything in here. And okay, so I'm gonna refresh the page. It says this page was requested 1 times. Proper English, by the way. 3 times. 5 times. This is very interesting. You guys know what the fuck is going on? Who knows? Why does it increment by 2? Favicon, yes. We have to... God damn it. God damn it. Favicon. It's goddamn Favicon. This page was crazy. So I suppose we can fix that on the level of the router, right? Because in a router we can just only specifically look for, you know, for slash, right? Only specifically look for a slash. Porth is a silly toy programming language. Porth is a silly toy programming language. Yes, it is. Very silly and very toy. Okay, so let me see. So this is like a hello page, right? And I suppose in here I can just like do something like, I don't know, slash streq if. So that's what we have in here. And if we try to query anything else, obviously what we have to use, we have to send 404, right? So let's go ahead and do that. So this is going to be 404. So I'm not sure if you have to, what do you have to put in here? Not found? I'm not sure. Not okay. I think like everything after this thing is kind of ignored, right? Oh, by the way, I think we got some subs. Thank you so much, Matt Kruger, for Twitch Prime subscription. Thank you. I really appreciate that. And Nichlete, thank you so much for 5 tier 1 subscriptions. I also appreciate that. And everyone who got the subs, welcome to our Epic Porth Club. Thank you so much. I'm sorry that sometimes I miss the subs, but yeah. So I'm just like super focused on this stuff. I think like everything after like here is basically ignored anyway, so you can put whatever you want in here. So connection closed. So let's say 404. Right. So this is 404, and here we're gonna just remove all of that. So yeah, a simple router, literally simple router. Super simple. Okay. So and now I can try to actually query something that doesn't exist. 404, right? So then I go to the root and here it is. And when I refresh, it actually doesn't jump by 2, right? Because for a favicon, we return 404 and we don't increment the request count. And it's actually pretty cool that, yeah, you can put anything in here and it will say 404. And then you can say quit and that shut it down the server. So, yeah. Pretty cool. I can restart this entire thing, and now I cannot restart. Something about binding the ports I still don't understand in TCP, but that gives me an opportunity to go back into my 6969 port. So I remember there was like some sort of a flag to sort of like reuse the bound ports, but I don't remember how to use that. So let's refresh this entire thing. This page was requested 3 times, 4 times. We can also try to come up with some sort of like a persistent storage, right? We can save this value in a file system, right? And every time we load the application, we also read the value from the file, so it can survive between the, you know, between the runs. But anyway, so that's pretty cool. What the fuck? Anyway, let's actually put all of that stuff into the standard library, right? So because I think it's going to be useful in the standard library, and also put this example into the examples folder, right? We have like a lot of different examples in here. by the way. We have a lot of different examples. For instance, we have a quine written in Porth. I wrote a quine in Porth, and it does work. Believe it or not, it does work. Do you guys want me to demonstrate you how it works? I can demonstrate you. Why not? So, all right. So I'm gonna do something like Porth. I'm gonna do example quine. For those who doesn't know, by the way, quine is a program that prints its own source code. Right. If you think it is easy, try to implement one. Of course, you can always use some cheating techniques in some languages where you literally can just get the file and print the file. Like I think in Python, you can get the path to the current file and just print yourself. But try to, like, you know, not assume any special features and just like try to print whatever source code you have, and you will realize how difficult it is, because you sort of go into this a paradox, like in a recursive paradox. Right, so if I try to run this entire thing, right, so just a second. Here is the source code. Here's the output of this program. In fact, there's a lot of output in here generated by the compiler, so I have a special flag -s, which actually suppresses all of that output. So here is this thing. So I want to save this entire stuff into quine 1.porth, right? So here I have two files, the original quine program that I run with the compiler, and the output quite1. So if I do diff u, what's the difference between examples quine porth and quine 1.porth? It's broken. All right. So yeah, it's kind of funny that it's broken now. Why is it so broken? All right. So I guess we have an opportunity to fix that. Right, so we have an opportunity to fix that. So let's go ahead and fix that. So the usual way I'm fixing this entire thing is the following way. So I wonder, is that because I changed something? So just a second. How my stuff didn't catch that? Oh yeah, I see. I see what's going on. Yeah, okay. So I broke it after I introduced the main procedure. So Porth didn't used to not have a main procedure. Right, it used to not have a main procedure, so now it has, and I modified it, and that was not catched by the test system because this is basically the expected output. Okay, let's go ahead and fix that, and I have an opportunity to actually explain how I approach quines. Right, this is not the only way to approach quines, but this is how I usually approach it. So essentially, in my quines, there is this blob of text, right? There is this blob of text. And this blob of text is actually quite important. So it sort of represents this code, and you need to put some sort of an anchor for that blob of text in here. And I usually use the question mark as an anchor. Right, so, and this is basically the string that I need to put into here, right? I need to take the whole source code in here and put it into this string. But what I need to do, I need to basically escape all of these special characters in here, right? So I need to escape those. So let's go ahead and try to do that. So I'm going to query replace all of the slashes with double slashes, right? So this is what we're going to have in here. So I suppose I also need to replace all of the quotes with slash quotes, right, to escape those. And I'll need to replace all of the new lines with the slash new lines. There we go. So that kind of creates the blob that I need to put instead of this question mark in here. So that's how I approach that. And then I have a code that basically iterates over that blob and restores itself. And then once it sees the anchor, it just prints itself the second time. That's basically how I do that. And I hope I didn't make any mistakes in here. Looks like I didn't. So that should be fine. All right. So, and this is how I update this quine every time, right? So I just do that manually, so to speak. So I'm giving out all of my secrets in here, right? All right, so I just run it again, and in Quine1, I have the output, which kind of looks like the original program, right? I think it does kind of look like the original program. And let's actually confirm that by diffing them. And as you can see, they're absolutely the same. So, saved. Saved. So yeah, so like it's actually quite good that I tried to run this Quine. Otherwise, I wouldn't notice that this Quine is broken. But that's how I fix it. That makes sense? Makes sense? Hopefully. So if I try to run the tests right now, I think they're not gonna work. So yeah, so basically the program that runs itself. Essentially. Example quine.porth, and if I try to run it, it will say that it's not working, so I'll need to update output. Okay, so this is one of the examples that we have. I think another interesting example that we have is, for instance, game of life. So the game of life works in a console, right? And it acts like a proper game of life. I can also show you. So this is basically the things that I implemented in my language, right? Porth, run, example, game of life. So this is game of life. So this is a bunch of gliders. Yeah. That basically live on a very small area in here, and this area wraps around. So pretty cool, huh? I think it's pretty cool. And another very cool example that we developed recently, of course, we have a snake game. But with the snake game, I still haven't properly figured out how to set the terminal, you know, in a proper state yet, so I'm still figuring that out. But so you have to use STTY to like set the state of the terminal like manually. So if I do something like this, here is the snake. So here is the snake written in Porth. And now we have HTTP server. So just recently we implemented HTTP server, HTTP Porth. There we go. So then this is what we have. A simple web application. So who knows what's the difference between web server and application server? Who knows? All right. So I guess I'm gonna clean up everything after the stream. I'm gonna just pull off some of these like small little things in here into the standard library, and then move this HTTP server into the examples. Does anyone have any questions? Does anyone have any questions? Isn't setting terminal state just printing special byte combos? Not really. I'm not even sure about that, but to set like no echo, I remember that you're supposed to use ioctl, right? So you have to take the file descriptor of the terminal and you have to set ioctl, but maybe you can set some special codes without ioctl. I'm not even sure, but I'm still researching that. It's not like a high priority, so I don't know. In this case, you could also encode the entire program in base 64 instead of escaping only special characters. Yeah, that's actually also a good idea, I suppose. What's Porth written in Porth? Yes, Porth is written in Porth actually. So the compiler itself is here. It's called porth.porth. Right, and if you take a look at this entire thing, it's almost 5,000 lines of code of Porth, and that is the compiler implementing itself, right? So, and essentially you can try to compile the compiler, right? So I'm compiling the compiler, and then it generated Porth executable. So I used Porth executable, it compiled itself, and then it replaced itself. So the next time I try to recompile it, it again recompiles itself, and again it recompiles itself, and again it recompiles itself. So it's written in itself, right? So it's a single file and it's self-hosted. Is there a way to represent fractional numbers in port at the moment? Well, you have an access to individual bits of numbers. You know what to do. If you're brave and also know IEEE 754, you can even use floating point numbers. Alright, I guess that's it for today. Thanks everyone who's watching me right now. I really appreciate that. Have a good one, and I see you on the next Azuzin session. So yeah, and let's maybe rate somebody. I don't know, is anyone streaming anything interesting on this epic website called twitch.tv? Have you guys heard about this website, twitch.tv? People stream some different shit in there. What I need to learn to do things like that? Patience. That's 100% first thing that you have to learn. Patience. Without the patience, you won't be able to learn anything. All right. And I'm not even joking, by the way. Seriously. I'm programming for 15 years. So, not that much. Like, there is people around who are programming more. Twice as more, even thrice as more. But still. So, who would you guys recommend to rate? So, I don't know. The website is very slow. I think it should be rewritten in port. Oh, got him. Got him. I'm joking. Where can I find the syntax highlighted for port? In the editor folder. So there is a folder in here in the source code, and we have extensions for Emacs, Vim, and Sublime. Okay, good. So we've been doing web development, right? So we need to rate somebody who's a web developer. So we have a web dev working on Gumroad and chatting. Okay, so I don't know who that is, but they're doing web development, and we also been doing web development, right? So let's actually rate them, right? Because it's like a similar content. Will there be a way to work with OpenGL and port? Absolutely. Absolutely. Yes, 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 yes. But we need to be able to dynamically load libraries, because usually you work with OpenGL by dynamically loading the libraries. So, yeah. We'll have everything eventually. Don't worry about that. Oh my god. Okay, so get ready for the rate. Oh, that's pretty cool. First time. Oh, I thought it's like it's Twitch telling me that I'm first time chatting. It's somebody else. All right. So get ready for the rate, boys and girls. Get ready for the rate. And this is so slow. My god. I need to stop it. Get ready for the rate, and I see you all next time. Love you all.